I will introduce you to a method and a toolbox I developed over the last 5 years. It's called Data Strategy Design, and the method, the toolkit is called Data Strategy Design. It's all open source, so everything I will tell you in the next 20 minutes, you can adapt and use for yourself. You don't have to pay anything, or you don't have to give me your data, by the way. It's really completely open source. You can download it. And after my introduction, Martien will show you a concrete example. And Martien was also one of our clients, and now he's one of our partners, also doing data strategy design workshops. So let me first introduce myself. So yeah, my name is Martin. I'm the founder and managing director of Datentreiber. And I started my career as an IT developer, and then I studied bioinformatics. So you would say today you would call it data science for the life sciences. And I studied at the TU, the University of Munich, and the Technical University of Munich. And this was also when I first came in contact with the UnternehmerTUM and also with design thinking, because I was allowed to participate in the Manage&More program of the UnternehmerTUM. And the first thing they told you is that if you want to succeed in business innovation, you have to change the way you think. You don't have to think technically, but you have to think from the user perspective and think about how you create a business impact. And one of our first projects was a project together with IDEO, the inventors of design thinking, and they taught us how to do design thinking. And this was about 15 years ago, I think so. And I think really this was, for me, life-changing in a sense that after that, for all my projects, I applied this design thinking method to all my venture projects, to my company buildings, but also for our clients. And I mean, if I look back at my study, I mean, this was one of the things that helped me most during my life, to have this mindset of getting into the perspective of the user and really think about how to solve problems from the user perspective. So, by the way, thanks UnternehmerTUM for this incredible experience. And I hope to give something back today, because we did over the last 5 years, we applied this design thinking method to data science projects or to data products. So we adapted the method, and we also invented some tools in order to create successful data strategies and data products. And so, and often this is called not design thinking, but data thinking. So I would call it data design thinking, but often people just call it data thinking. And so why do you should think about data before analyzing data, before doing data science, before developing or engineering a data product? And the reason is very simple, because most of the data and analytics projects or AI projects, they fail. And there are different studies, and the number differs between 60% or 85%. But I mean, even 60% is way too high. So this means that more than every second project fails. And of course, the question is now, why are so many data analytics and AI projects are failing? And I think one reason, and we know this from our experience over the last 5-6 years, and I also know it from as the experience as a bioinformatician when doing data science for the bioinformatics, often there is no business impact, because the data scientists are too focused on the analytical or technical part, and for example, about thinking about the model performance, so how to increase the specificity or sensitivity of their models, but they are not measuring the business impact. And there's a difference between the model performance and the business performance. The model performance tells you how good your prediction model is, for example, but this has nothing to do with the business performance. The business performance is measured in euros. In euros, you make more revenue or you save costs. And another reason is that often solutions are not accepted by the user because they don't solve a user problem, or they don't help the user to achieve his or her goals. And often another problem is that they don't understand how the solution works, and so they are skeptical and they don't use it. Or what I learned during a lot of projects is that often when you talk about analytics and you talk to business users, they have the feeling that it's just used to control them, to optimize them, and to monitor them, but it's not used or not provided to them in order to help them. And so often projects fail because of no user acceptance. And the third reason is often there's a lot of data, but it's not the right data. And meaning right data, it's not the quality of the data is not good enough, but also often it's really the wrong data, meaning that, I mean, often companies start collecting data and it's like collecting garbage. So they just collect all the data that is generated by the IT systems, but they do not think what data do we need in order to extract specific information that helps us to make better decisions, that results in actions that lead or help us to reach our goals. And this is what you have to do when you think about it. For example, a data strategy, you have to think first about the company objectives and then go back and think about what is the information we need and where can we find this information. And so you have to really collect data with a specific objective in mind and not just try to find, I mean, the gold, there is this term data mining. It's about thinking about, yeah, finding the gold nugget in the data garbage. And often this goes very wrong, because if you have enough data, you always will find correlations, but those correlations won't help you. So why do we need a data strategy? In order to avoid those three reasons why data projects or data products fail. And this is about feasibility, and it's the same for innovation projects as for data projects. So the solution has to be feasible, so it has to be working from a technical and analytical point of view. So there must be the data in a sufficient amount and quality. And it should be also desired by the user. If users don't want a solution, they won't use it. And if they won't use it, there will be no business value. And a solution has to be viable. I mean, you can spend, of course, 1 million euros on a complex AI solution, but if this solution only increases your revenue by 10% and you just make 1 million euros revenue, I mean, this is not a business case. It doesn't get you any return on investment, or you have to wait for 10 years until you get the money back. And often this is also one reason why those projects fail. So, and of course, the difficulty here is to identify those innovations that are viable, desired, and feasible. And of course, you have a lot of options, but only a small portion of those options are those viable, desired, and feasible data products. And so what's the data strategy? And a data strategy is all about, so what data do you have? So what, or also what data you could have? So what data is accessible? And then think about what are the relevant analytics use cases from a user perspective. And then also think about what are my company objectives? And also the combination of, okay, there must be a use case which is, or which depends on accessible data and creates a benefit for your company objectives. And those are the data products you want to design and develop. And those are data products with a business case. And those are the data products that will be successful at the end. And what we designed over the last few years, we call this a data product innovation cycle. So we thought a lot about, okay, how can we help our clients to innovate successful data products? And of course, it all starts with the data sources. They have data, but what they don't have is often they don't have a data strategy. So they don't have an idea what are the relevant use cases. And the use case means you know the problem, you know the solution from the user perspective, and you know also the benefit for the user. And then you have to define a roadmap. So what will be your next use case, your next best use case, and what will be the real business case behind each use case? So what will be the costs implementing this use case, what will be the risks, and what will be the profits? And often you have a lot of, for example, we had one client, they had about 100 different analytic use cases in mind. And in the end, there were 3 data products they developed. And all the other use cases, they didn't solve a real critical user problem, or they didn't create profits that justified the costs and risks. And this is what a data strategy defines. And the way to get to this data strategy, that's what we call data thinking. So how do you get from the data to a data strategy and think about the data products? But the problem with the data strategy is a strategy is just an assumption, a collection of assumptions. And so you have to verify or falsify those assumptions. You have to test whether what you designed will work in the end. And this is what this is why you develop data prototypes, to check your assumptions and to learn about the solution and to learn about the users and the business. And for this, often it's the classic data mining approach, where you design models or where you train models and then verify or evaluate your models. So we will come to this in a few minutes a little bit more in detail. And then when you check all your critical assumptions, then you will start building your data product. And a data product that is something that turns your data sources into something of business value, that helps you to make better decisions, or that automate and optimizes decisions, for example, in an AI product. And here, data engineering is the important part. And often what I learn from German companies, they're very focused. I mean, Germany is this country of engineers, and they are very good in engineering, but they forget about the data thinking and also about the data mining. And I mean, I started my career as a software engineer. I learned about UML and how to build software architectures and all the things. And then I studied bioinformatics and did data science. And it was more, yeah, let's do quick and dirty, write R code and test this hypothesis and check the data. And for me, it was quite a culture shock, let's call it this way. And I think this is also the reason why you have to separate those two different phases of building a data product. And also what's important, you have to manage your data product. You have to manage the data. You have to check, you monitor it, check for anomalies, for missing values, and so on. Because once you know how to turn your data sources via a data product into business value, you're not talking about data sources, but you're talking about data assets, because you know that they have a real data value, a real business value. And then you have, I mean, if it's an asset, you have to manage it. This is often what is forgotten. To manage those assets, you need data stewards and so on. And to dive into a little bit more details about the data thinking, it all starts with the business understanding, to check or to identify the viable use cases. Then you have to dive into the user understanding to identify the desired use cases, and also have a good data understanding. And then you go in the next phase into data exploration preparation, because if once you know what are the relevant data sets, you can explore those data sets in more detail. No? And then you do the modeling, the visualization, you evaluate your models. And often it's not a linear process. Often you go back, you learn something new, you have made wrong assumptions. And yeah, it's, as I said, it's more like a lot of cycles in a bigger cycle. And once you got your proof of concept, then you start building your data product. You also have to measure whether this data product really works, is used by the users. You have to learn how to change it. And when it's deployed, you also have to orchestrate it together with other data products, because often you have those data and analytic pipelines that can become very, very complex. And you have to monitor all the incoming data, but also the outcoming data, so the predictions, information. You have to monitor your model performance, whether it fluctuates or goes down. And maybe you have to rebuild or adapt your solution, or even you have to continuously also check the value, and maybe you have to redesign your solution, because I mean, Corona is the best example of a so-called black swan event. All the predictive models, for example, for sales forecast didn't work a few months before, because the world changed, and maybe then you have also to change your model, your data products, your AI, whatsoever. So maybe you recognized the right side. This is the so-called cross-industry standard process for data mining. But what's missing at the crisp DM process is the user understanding. And that's why we combine those crisp DM together with design thinking. And on the left side, you see, I mean, you will probably recognize this. This is the classic lean development or lean approach. And this is the so-called data ops approach. And yeah, that's why we are talking not only about data thinking, it's a combination of data and design thinking, or data design thinking, whatever you want to call it. And also, it's not only about data mining, it's also about doing user experiments. That's something often data scientists forgot. So you just check the model performance, but they don't, for example, check the user experience. You can do, for example, a wireframing experiment or so. And of course, it's not only about data engineering, it's also about good software engineering practices, about UX or UI engineering. And yeah, you don't only have to manage the data, you have to manage your models, you have to manage the product. We will have a course about AI product management together with the Digital Product School in a few weeks, because that's becoming, the AI product manager becomes a real critical role for companies. So how do you design, or how do we design a data strategy? As said, so it should start with the business understanding and then go into the data understanding and then into the data understanding. And that's what we call data strategy design. And what do you need for data thinking or the data strategy design? Or who do you need? I mean, as said, you need a business understanding, so you need the business units. And this is really critical. You have to involve the business unit, for example, the marketing unit, from day one into the process of designing and developing a data product. And of course, you also need the people from the data science department or data analytics department. And often you also need the IT guys, because they sit on the databases, they sit on the data, and they know what's the data quality, and they can give you data access. So often data strategy and data product projects are very interdisciplinary, and it's hard to get them to work together. And this is also why we invented those data design thinking tools. And yeah, what tools do you need? I mean, the most important tool you already have, that's your head, or I mean, your brain. And I think that's the reason why this event is called Data Brain, because without our brains, no data product would, or no AI would ever work. And by the way, I mean, our brain is the best analytical tool known in the universe right now. There is no better one. We don't know any better one, and you have to train it and you have to use it. And yeah, of course, we also recommend to use, for example, such canvas tools. You can just use it with pen and paper, but of course, there are also, in times of Corona, we also, of course, provide them in a digital version, for example, shown here. And we use this canvas template to design data strategy design workshops. So together with our clients, we think, okay, how should we design the process of a workshop where we want to design a data strategy or design a data product? And for example, here, this could be, or this is an example that will be shown in more detail by Martien in a few minutes. And this will be a workshop about how to design an AI product for a manufacturer. And often we do a 2-day workshop, and the first day should be about an overview of the current situation and also an outlook, show what are our objectives. And the second day is more deep dive into the technical and analytical details, because at the end, you don't want only to have a data strategy that is, okay, a bunch of PowerPoint slides. What you want at the end is a concrete, I call it always the next best project. So what's the next best project, and what are the critical assumptions that we check first before we invest time and money on this project? And so the second day should be really about going into deep details. And for example, each workshop should start with an introduction, with the objective, participants, agenda, also an overview of the methods and tools. And then the first step should be going into the business understanding, because without a proper business understanding, your solutions won't be viable. And for example, this could be that you start with analyzing your business model, and then, for example, focus on one critical process, and then analyze this process and identify analytical use cases where analytics and data help you to optimize or even change this process so it's more effective or more efficient. And then once you identified a specific use case or multiple use cases, you should think about, okay, who will be the users of the solution, or who will be also other stakeholders? And then you have to think about what are the needs of those stakeholders, and then design the solution from the user perspective. This means not designing the technical part, how to solve this use case, but how to solve it from the user perspective. So what information and what functions you have to provide for the user so he can solve his problems with your solution. And in the end, you should come up with a so-called check problems. Should come up with a problem solution fit. So you check whether the solution you designed really fits to the user needs. And then it's about sketching the analytic solution, also identifying the relevant data, explore your data landscape. So identify the data sources that could contain the information, could contain the data, but also identify data gaps. And this is really the important thing about data strategy. It's also think about what data is missing and whether we should start now collecting this data so we can implement the use case next year or in 2 or 3 years. Because often people don't think about what data they are missing. They only think about the data they have. And so they lose a lot of time, because in 2 years, when they want to implement this use case in 2 years and they didn't start collecting the data today, they missed data for 2 years. Yeah, and this is about, as I said, identifying the data assets and gaps. And then you should also, at the end, evaluate your business case and also identify those critical assumptions. And the critical assumption could be also, okay, could we really find the relevant information within the data sources? So often the next step is the data exploration and check for data quality and things like that. And for those different steps, we provide different Canvas tools. And Martien will show you some of those different Canvas tools in a few minutes. There's, for example, a business model Canvas tool. There is a value chain Canvas tool, a data strategy Canvas tool, a data landscape tool. And this is an overview over the different Canvas tools we are offering now. You can combine them, so they are designed in such a way that you can use them together. And there are also a lot of tutorials and information or examples online. And if you want to know a few companies that already adapted and are using the data strategy design method and toolkit, here are a few examples, a few of our clients. There are even more. And of course, if you want to get started, here are a few links. So there's, for example, here you can download the design kit or the Canvas tools from the design kit as PDF or PNG files. There's also a LinkedIn group. And there's also, this is a commercial video training where we show the method. We also offer, of course, trainings. There will be also an English speaking and virtual training in a few months. There will be a German training at the end of the year. If you want to be up to date on new developments about the design kit, just follow us on Twitter. And there are also a lot of, as I said, presentations, for example, on SlideShare that explain the method and also give you further examples. And also, of course, we will upload this presentation on SlideShare after the meetup. And I think now I have talking as every time too much, so I pass on to Martien.
Okay, thank you, Martin. And actually, you did very well with the timing because it's exactly 1/2 and that is what we were aiming for. So it's
great.
Super well. My name is Martijn. I'm based in Amsterdam. Let me start to share my screen. And I'll put that in presentation mode. Yeah, there it is. Okay, you should be seeing my screen. And yeah, just a little bit about me. My branding is a little bit that I'm all about transformation because I've always been working on projects my entire working life. The last 12 years or so purely as a project or program manager. The last 2.5 years, I've been focusing on the very interesting topic of digital transformation. And that is also where I met Martin. He trained me. I did the entire training program in the data strategy design method. And I started to roll that out in my previous company. I'm saying previous because I'm one of those guys who was made redundant as a result of a corona crisis related reorganization recently. But I rolled out the data strategy design method. I trained people in that method within my company, and I hosted a number of workshops. And most recently, I've been using the opportunity to have more time to study more about design thinking. So I just completed my 6th design thinking course this year. Because that is really the key method to use for digital transformation projects. And of course, it's also the basis of the data strategy design method. So I'm trying to move to the next slide. Yeah, now it does. Okay, I don't know what's happening. Anyway, I'm going to discuss an example in the next 43 minutes. It is really a fictitious example. The past 17 years, I worked in the automotive industry. I actually worked for Meritor, which is a manufacturer of axles and brakes for trucks. But in the example that I used the example of a gearbox company. As Martin explained, normally these data strategy workshops, they take about 2 days. So I'm going to summarize that in 45 minutes. Yeah? So in that sense, it's high level. And also I'm going to do that, let's say, in a sequential way. So I'm going through the canvases one by one, and I just show you the final state of the canvases. Whereas normally it's very interactive. So you work on one canvas, you move to the next one, and then you realize that, oh, well, actually we need to change something on the first one, etc., etc. Yeah? So you'll miss that today. All right. Now I can move to the next slide, so that's nice. A gearbox. I think you all know what a gearbox is. That's that thing in your car that, and you have either a stick shift gearbox or an automatic one, which you see on the right one. So that is what I used as an example for today. It's a relatively complex project with quite a lot of parts. I mentioned some of the main parts here on the left side, and that is what I use as the example. However, the example use case that I will discuss today could basically be valid for any manufacturing company or any company with a warehouse. So it could be any wholesale distribution or any other company that's storing a lot of product. Okay, as Martin explained, the first step is really to discuss the business model. And so during a workshop, you go through this box by box and you brainstorm on each box, and then eventually you end up with something like this. And this business model, this really helps to set the scope and to get everybody aligned on what we're talking about. And then really the purpose of this particular canvas, I will not explain it in detail. I think it is rather obvious. It's about the gearbox company and talks about the customers, the products, and then of course also the partnerships, well, the costs, etc., etc. So I think that pretty much speaks for itself. But what you also do here as a next step, during the discussion, you find the areas that need some attention. And during these workshops, although the workshops are meant to identify and work out data analytics use cases, you also always come across all kind of other issues, because you're going through all these canvases. And that is actually, I would say, added value. So you do note these and you just transfer them, let's say, to the applicable teams after the workshop. So in this particular case, I made, for example, electric vehicle gearbox red, because as you might know, we are of course transferring to electric vehicles. And as you might know, the vast majority of electric vehicles do actually not have a gearbox. We start to see exceptions. So, for example, the Porsche Taycan, the first electric vehicle from Porsche, actually has a 2-gear gearbox. So maybe that's something that will develop further. But obviously, if you are a gearbox company, you need to start thinking about what you're going to do with your product strategy going forward. So that's why I made that red here, because again, in the fictitious example, this company didn't think about that yet. Hopefully that's not true in the real world. Now, there you see 2 yellow notes. This company has some challenges in the supply chain area and in the actual manufacturing area. So that is what I will focus on in the rest of this particular example. By the way, you can of course use these canvases in all kind of different ways, and it also really depends on the scope and the topic of your workshop. But typically the workshop, you want to focus on a particular area of the company. So this business model is very high level for the entire company. But if you already know in advance that you're going to talk about supply chain and manufacturing only, you will make actually a business model just for that part of the company, to set again the scope, and that also gives an easier transition to the next steps. Now, as a next step, we are using this value chain canvas to really have a more in-depth look at that manufacturing and supply chain process. So we do that for supply chain and operations. So that is the topic here at the top. Then we start looking at, okay, so what are the customers and what is the final product for this company? In this particular case, making gearboxes and making the components for the gearboxes to sell as spare parts. And the key customers would be car and truck manufacturers plus wholesale distributors who will sell again the spare parts to dealerships and other companies. Then you start to look at, okay, so what units do you have in this supply chain and operations area, and what are the key activities? And in this particular case, you will see that there is a whole process which actually the responsibilities are sometimes with supply chain and sometimes with operations. Yeah? So if you go through the process from left to right, so this is just a high-level process which is basically valid for any manufacturing company. Well, you do your supply chain planning, then you order the parts, you receive them, you inspect them, you stock them. Then the manufacturing or operations team does actually the manufacturing scheduling, so the scheduling of the actual production. And they will also already start to schedule the transport, because everything in automotive, it's just in time, and if you schedule production, it's just for today or tomorrow, then you produce and then you ship as soon as possible. And then you get the actual manufacturing. And here, of course, it's just displayed with a few notes, but in reality, if you have a big automotive factory, you have within that factory a number of production lines. You typically have a final assembly production line and multiple sub-assembly production lines, so they feed that final assembly. And then before that, you typically have a whole machining area. So, and in that machining area, you make the smaller parts, which again feed the sub-assembly and the final assembly. Plus, of course, part of the product is, we also saw that on the previous canvas, part of the product is procured from suppliers. So all in all, there are in a factory, if you've ever visited a factory, there are an awful lot of movements of product. So there's forklifts driving around everywhere and moving components from the warehouse to the machining area. Then they're being machined. Then they may go back into the warehouse again. Then they feed the final assembly line and eventually the sub-assembly lines, and then eventually the final assembly line. So a lot of forklifts driving around and a lot of material moving around. And then, of course, eventually, and that is, by the way, what I mean here with all these arrows. So you're picking the components for the assembly, for the sub-assembly and the machining. Then it may go into stock again, this arrow. Then eventually you go to the final assembly. So that is visualizing all the movements. Yeah, what I tried to explain. Then eventually, once the final product is finished, you will ship it to the customer. Yeah? And in the automotive industry, there's a lot of sequence deliveries. And so often companies like this, they will need to deliver the gearboxes just in time to their customer, which will be a car manufacturer. And they will just arrive before the cars, which they're meant for, are going over their production line. And typically, the gearbox manufacturer will have to deliver in the sequence that the gearboxes are used on the production line. So this whole supply chain is connected. That is something typical for the automotive industry. Anyway, if we continue with the canvas here, now the base product, of course, a lot of steel and components from all kind of other vendors. And then you really go into the next tiers of the supply chain. So a gearbox manufacturer would be called tier 1 supplier, but they have their suppliers. So these are the tier 2 suppliers, etc., etc. As a next step, yeah, you identify the suppliers here. Well, I already partially covered that. And then you start to identify your use cases. And in this step, in this method, a use case exists of a problem, a solution, and a benefit. So those 3 components. And here you focus actually on the first step. So identifying the problem, because that is really where you need to start. So you start to brainstorm, okay, which problems do we have within this process? And in this fictitious example, I came up with these areas, yeah, so quality issues and material shortages, well, all kind of examples. And actually the problem that I will continue with in the rest of the example is all this handling. Yeah, so that is what I just talked about, all these material movements between these different workstations and the warehouse, how to minimize that, because any unneeded handling is waste, and you try to avoid that to reduce costs and also to increase your throughput and your total lead time. So that is what I will focus on. Normally, there are actually some canvases that can help you with identifying what is the best use case to start to work out further, but I will skip that part over here. There are some great canvases for that, and I will just continue with that particular problem. So then we actually skip a few canvases here that you typically use in between. Optionally, you can also use a canvas to identify the actual user of the solution. But here I'm going to really work out the problem in more detail. And this is typically something that you typically already do on the second day, not on the first day. So this solution is for, well, what I call the materials handling analyst. Yeah, so somebody whose job is to make sure that the material handling is minimized. Yeah, because any unneeded handling is waste. And then you start to identify first the objectives and the results. Yeah, so the whole right part of this canvas, the circle, that is all actually about the current situation, yeah? Because any data analytics use case, as I learned from Martin, it always has a competitor. Yeah, it always has some existing solution, and it can be completely manual, maybe with Excels and all kind of manual things, or partially automated. But there is something in place that tries to take care of this process. So starting with those objectives and results. Well, the final goal is, of course, to minimize the handling as much as possible. And you do that to reduce the cost, because any handling that's not needed is waste and therefore costs money. And also to increase the throughput, yeah? So to reduce the total lead time of the process and make sure that you can make more products in a shorter time. Now then, starting to look at the decisions and actions related to that. I'm skipping a step, as you can see. So here you define the relationships that I just explained with the arrows between the objectives and the results. And then looking at the decisions and the actions. And again, I'm just showing you here the 4 notes, but this will take some brainstorming to get them in the right sequence and to really be clear on what the current process is. But I just put them here in the final sequence. So the current process really starts with gathering the inventory transfers. Yeah, so from the warehouse management system, you can gather all the transfers that have been done during a certain period. Yeah? And then typically what companies do, they do like an ABC analysis. So based on that, they categorize the products. They say, okay, this is the product that is transferred the most often, and this is the product that is transferred the least often, and then there's maybe some in-between category. And in that way, they categorize the products, the fast movers that are transferred a lot, and the slow movers that are not used a lot. And then, of course, eventually in the way that you set up your warehouse and you allocate the default locations of each component, you use that ABC analysis, yeah? Because in that way you can put the components that are transferred most often as close as possible to the destination where they usually go to, and the ones that are used least often can be a bit further away, and in that way companies try to minimize their handling. Yeah? So based on that ABC inventory analysis, they optimize the default locations by product every now and then. Yeah, just as I explained. And then if needed, so if they need to change some of those default stock locations, they may for one time transfer some stock to make sure that everything is again in the optimal location. So this is a process that is done every now and then. The frequency will depend a bit on the company and the nature of the business. Now, all this, of course, relates or leads to minimizing that handling and therefore minimizing the waste. So that is what the company currently does. Now then, as a next step, you start to look at the pains and the gains. So which things are not going well in this process and which things are actually going well. So I just identify one pain, and that is that, yes, this ABC inventory analysis is always based on history. So it's actually, it helps, but it's never accurate. Yeah? For today, especially not for tomorrow, when things may be different again. Now, on the positive side, it does reduce the handling, but it doesn't reduce it as much as you could, because again, it's always based on the history. Now, then as a next step, you relate these items to the applicable node, the applicable step in the process. Yeah? So that ABC inventory analysis, that is the one that is based on history, and therefore it's always behind. And yes, the handling is reduced, but it's not really reduced maximally, because again, it's always based on the past, on old data. So that is for the current process. And then as a next step, you start to define your solution. And this is really about, the user, the end user, dreaming its solution. What would he actually like to get out of this? And this is where you get very pragmatic. So typically, this is also where you start to make some wireframes, like if you make a dashboard or something like that. Okay, how will that look like? And what will you do? Where will you click? What will you get? So that you make it very, very practical and tangible. Yeah? Now, in this particular case, I didn't make a wireframe because the example is relatively simple here. Otherwise, it would also be hard to explain in 45 minutes. So in this particular case, I defined, well, there should be 2 metrics. One for the receiving handling time and one for the production handling time. And I split them because, of course, the receiving is done based on your supply chain planning. So if you know that your production volumes will increase in the near future, you will already start to order more product with your suppliers, because you want to make sure that you will not run into any shortages, because then you are in trouble. Yeah? So typically the receiving volumes, if the production volumes will increase, the receiving volumes will increase earlier in time. That's why I split it between production and receiving. So the metric is really about the handling time. Yeah, what is the handling time, and then relative to the volume. Yeah, so relative to the production volume for the production handling time, and relative to the receiving volume for the receiving handling time. And then what the solution should eventually do, it should really prescribe default stock location changes. Yeah. But now, since this is going to be a prescriptive solution, this should not be based again on the historical data, but this should be based on what we expect to happen in the future. So that is the idea of the solution. And well, what benefits will that give? Well, then you can really maximize your handling reduction. You can maximize your cost reduction related to this process, and you can maximize your throughput related to this process. So that's the idea of the solution. Then what you will do, you will actually check if what you defined on the left side, if that takes care of everything you identified on the right side, if this solution is really a good match for the problems you had. Yeah? And again, this is a simple example where I just defined one pain and one gain. In reality, the canvas will probably be more full with many more nodes. I see Martin smiling already. So yes, he has that experience as well. So in this way, it's relatively simple. Yes, our problem was that yes, we do an ABC inventory analysis. Yes, it helps to reduce the handling, but since it's always based on the past, it is always behind. And now, since this is going to be a prescriptive solution and it's going to be based on the now and the future, you won't have that problem anymore. Yeah? So it does match that. So therefore, we say yes, the match is okay. And now we actually also realize, like, oh, what have we actually developed? Yes, that is a prescriptive stock location optimization solution. That is actually what we have invented here, the idea of that. Yeah? So that is the analytics use case canvas. And I actually hid my my chat box here, so I don't know if any other questions came in the meantime, Avi, but if so, please let me know. I like it if you ask questions also during the presentation. That makes it interactive. Although I may sometimes decide to answer the question at the end of our session today. That depends on your question. Okay, so let's move on to the next canvas. Here I move into the data strategy canvas. Yeah? And so this is the data strategy for our prescriptive stock location optimization solution that we just defined. And yeah, what I really like in this method, I also remember Martin telling that in his first training, he makes this analogy with oil. You see some of the symbols here that you might recognize from the oil industry. And I remember his story was that data is considered to be the new oil by many people, but that for the data strategy, you actually need to follow the opposite direction than in the oil industry. So you need to start with the utilization, you need to start with what really your problem is and what your solution for that is, and then based on that you can find a solution. And I think that is really one of the strengths of this method, because there's such a strong tendency to want to use the latest cutting edge technology and just implement that and not spend enough time on what the real problem is. That is really the power, I think, of this method. So we do start with that utilization. Well, we've just been talking about that. So it will be a prescriptive solution to help with that ABC inventory analysis, but now based on expected demand rather than the history. Yeah? And what it's eventually going to do for the user, it will prescribe that the default stock location changes that you have to do to optimize your warehouse locations and to minimize, with the goal to minimize your handling within the warehouse and the factory for the future. So that's what we want. But now the refinement. What do we actually need to do to get there? Yeah? Now I just show you here the notes, but of course in a workshop this will also take some time to come up with this and to put it in the right sequence. So what you will do, you will first have to calculate the expected demand. Yeah? And you will do that by gathering forecasts, gathering historical sales, and then gathering any firm sales orders that you already have. And then based on that, you can calculate the expected demand. Yeah? This is also used in the planning process. Yeah? So this data will already be there actually in supply chain planning solutions that the company will be using. Now that expected demand is by final assembly. Yeah? So that is the actual gearbox that will go to the end customer. However, in the factory, we build that gearbox, and that gearbox exists of many, many parts, yeah, hundreds of parts. And the inventory transfers that we're talking about here and that we're trying to minimize, they are mainly the transfers of either the raw material and the raw components or of sub-assemblies. Yeah? So that is where we need the bills of material. And what is a bills of material? A bills of material is really a list of all the components that are in a final assembly. Yeah? So very simply, for a chair, the bills of materials will be the 4 legs of a chair, and then the seat and the thing that's in your back. So that is just 6, and maybe a few bolts and nuts to put everything together. So that's very simple, but for a gearbox, obviously, it's a lot more complex because there are hundreds of parts within a gearbox, and then there are like a couple of sub-assemblies that again finally go into the final assembly. Yeah? So you have to do the explosion to know which parts are actually being used, and then you will have to simulate all the inventory transfers that will have to be done to produce that one gearbox with all those parts. And then, of course, you have to do that for the entire expected demand. And a company like this will produce thousands of gearboxes a day. Yeah? So then, as a next step, you need to optimize that handling time metric. Yeah, so you have that metric to for the handling time, both for the receiving area and for the production area, as we just discussed. And with your simulations, you will have to optimize that handling time, and obviously that total handling time over a certain period for all the product that is being manufactured should be as low as possible, obviously. Yeah? So that is really the simulation and the optimization. And then based on that, again, you can simulate the ABC inventory. So you can do a prediction of what will then be the new ABC classification for all your inventory transfers. And then based on that, you can prescribe the default stock location changes. Yeah? So that is what needs to happen in the background of this solution. Now, then the next question is, okay, and what data do I need for that? Well, here I already gave the final answer, but typically at this stage of the workshop, maybe you will just come up with 4 of those 7 notes. Yeah, probably not all 7. And that is why we have another canvas to go more in depth on the data. So let's go there, and then we can also explain what all that data is about. So this is the data landscape canvas. And again, we're going to do this for the prescriptive stock location optimization solution. And yeah, as you might have noticed, in many of the canvases, different colors of nodes are being used, and they have similar, but in many times slightly different meanings depending on the canvas. In this particular canvas, green means that we have the data, red means that we don't have the data, and yellow means that yes, we have the data, but there's something with the data, and that typically it requires cleanup or things like that. So here you start to brainstorm about, okay, what data do I all need to make this solution? We just defined that in the utilization box, what steps you will need to go through, what logical steps to actually calculate or or come up with this prescriptive solution. So, well, obviously you need historical demand, as we spoke about, and typically you will find that in an ERP system like SAP, for example. You need the bills of material, and then you need the production bills of material. That is typically in an ERP system as well. Companies like this usually also have engineering systems, but that is more like the engineering bills of material, and that is not what you need here. You really need the production one, and then also the related routings. I didn't mention that specifically, but bills of materials and routings are something that, oh no, actually that's the yellow note, of course. Routing is really defining for each product which route it will take through the factory. Yeah? So it says, for example, to produce this gearbox or this particular part of the gearbox, it first needs to have a machining operation at this machine, then it moves to another machining operation and another machine in another area. Then it will go into stock again. Then it will go to a sub-assembly line where some other parts are added, and that will feed directly the final assembly line where it goes into the gearbox. So that is what a routing does. So you obviously need that data as well, because that defines where all the inventory transfers are going, related to the project. Now, then you need to know your default locators. That is for that, also for the ABC analysis. And as we said, we want to do a recommendation in the end on what locators we need to change. So in a factory, every product will have like a default locator. So if it's a component that comes from a supplier, when it's received, then the system tells, okay, this component needs to go, for example, to that location. Yeah? So that is the default locator. And also within the warehouse, again, that is to make sure that you minimize the inventory transfers, as we just discussed about. Now, then you need historical inventory transfers. That comes from the WMS system. You need the firm sales orders, again, to calculate the future demand. That's typically in the ERP system. The forecast as well, and forecast and also often firm sales orders typically come in by EDI, electronic data interface, and are being loaded in the ERP system. Yeah. Now, what is the real interesting thing here, and that is also where you see the colors. In this discussion, you will realize that you have some challenge, because with this solution, you want to minimize the movements, and to do that, you need to actually simulate the movements. But to simulate the movements, yeah, you will need to know what the routing is of a product, and then you need to know from which location in the warehouse it comes. Now, the WMS system contains all the locations, yeah, because that is the system that tells the forklifts basically, okay, transfer this pallet with product from that location to that location, and the forklift drivers just execute those tasks the whole day. But the routing data typically does not contain the locations, because it just talks about a machine or a production line. So that is where your challenge is. How are you gonna combine this? So you do not have the link between the routing information and the actual location where that is to simulate your transfers. So these are typical things that, yeah, you only realize when you go a little bit more in depth. And there are some suggestions, because, well, maybe you can add those because you have destination information in your WMS system. So you have to somehow relate that to your routing information, and of course to the right routings, the right locations and everything. So that are some suggestions. Those are typical things that take some more discussion. So you will not make a final conclusion on that within the workshop itself. And that's where the white notes come in. You have some actions to follow up on. Yeah. So here you have obviously some actions to address that red item here, like, yeah, we don't know that link, and how can we solve that in the most optimal way. I did 2 suggestions here, but that's something needs to be investigated and worked out after the workshop. Okay, so that on the data landscape, and then you really know, all the data that you need, and then you go actually back to your data strategy canvas, and probably in reality, then you add the other 3 data elements that you didn't even think about, because typically what you see when you have a bit more in-depth discussions on, with the help of the canvases on the solution and the data, then you will typically see that you need a lot more data than you initially thought. Yes, I see a question here. Let me take that directly. Yeah, there is indeed. I didn't explain that because it is not so relevant in this particular example. But let me just go back to the canvas here. It talks about owned data, earned data, public data, and paid data. And earned data is indeed something that you earned during the process from a customer or a supplier. Yeah, that is indeed correct understanding. In this particular case, we don't really have paid data or public data, but the canvas applies for that as well. And then indeed it breaks it also up in raw data, derived data, and linked data. And well, I did do that here because the problem here is really the linked data. How do we link those data elements together in the appropriate way? Yeah. I hope that answers your question. And if not, please unmute yourself and let me know. Yeah? Okay. So going back to the canvas here. Yeah. So as I said, at this point, you probably need to add some data sources that you didn't initially think of, and that is again also typical design thinking, diverging and converging, where you realize when you go through the other canvas that, oh yes, I actually have a few more data sources that I need to consider, and this is actually a little bit more complicated than we initially thought. That is typically how it goes. Although this particular example is not the most complicated example, because I wouldn't be able to explain that in 45 minutes. Okay, then, oh, and actually another question. It's nice. We get more interactive here. I like that. The devil is in the detail. Yes, Martin, you're right. Okay, so then you start to look at the tools, and in this case, I did this actually very high level. I also asked some advice from Martin here, because that is not really my area of expertise. Although I worked in business intelligence for a couple of years. That's quite a while ago. So we kept it a little bit high level here to be worked out in more detail later on. But this is where you need some specialists, of course, as well. So we said here simply, well, we think we need a data lake, we need some predictive modeling tool, and then we need some kind of dashboard visualization tool. And you probably need some steps in between. That's why we put them a bit far away from each other. I think there was another question. Yes, we leave this somewhere. And then now to finish this off, well, what people do you need? And Martin also referred to that. Yeah, you need also really to have that business input. And here I put that as functional ERP consultant, functional WMS consultant, but really people that understand the business process. Yeah? That is what you need to really work this solution out in more detail. Then, of course, to actually build a solution, because we need to do the modeling and everything. Then you go and need your data scientists and your data engineers. Yeah, I would say I didn't include that in here, but I put here functional ERP consultant and WMS consultant, but I would definitely also add actually an actual business person from the business team. Yeah, so that is important to have in your project team. And then finally, you look at your partners. In this case, I just said, okay, well, we have one data science consultants company that will provide one, but that is what you look at here as well. And then when you're a little bit further, you can also start those discussions with the partners. So that is then eventually your data strategy for this particular solution. And then with that, yeah, you're really rounding off your 2-day workshop, and you're ready to take the next steps to further, prepare and implement this project. So that is really the end of my, again, fictitious example. I hope it was useful. So thank you for your attention.